José H es Héctor.
No,
Humberto.
Humberto.
Oh, José Humberto Lugo.
Mhm.
That's your name. Okay.
Yes.
Excellent. Well, he is an electrical engineer, graduated from the University of Texas in El Paso. Okay. From UTEP, he's a minor.
Mhm.
All right, very good. With advanced studies in power engineering from Michigan Tech University. How about that? Okay. Right after graduating, his specialty became power engineering and volunteered to be subject matter expert on power transformers. How about that? That's something else. Throughout his career, his experience expanded to material equipment and engineering that require vast amount of hours and has resulted in supervising 5 other individuals, 5 other engineers, okay, to complete several goals each year to keep up with the industry and maintain excellence for the company. Well, what can I say? Congratulations. Your mom and dad must be very proud of you.
Thank you. And I would hope that they'd be proud of me.
All right. How
The
about
baby.
that?
Yeah.
He's the baby. Yeah. Okay, well, conduct your presentation, Jose.
Okay. So you want me to share my screen?
Yes, please.
Okay. Let me know if you can see it.
Yes.
Yeah, we can see.
Okay.
Power
Yes, sir.
transformer
Okay.
quality.
Right there, I can see it better. Yeah.
Excellent. So, as my introduction said, my name is Jose Lugo. I'm an electrical engineer for about 17 years, graduated in 2008. Currently, I am a supervisor for a utility in the Northeast, supervisor for the Standards Engineering Group. My specialty for this presentation will be being the subject matter expert for power transformers for a good 13 years. I have left that title recently since I became a supervisor. You can't really do both at the same time because you can't supervise while being a subject matter expert. But all the being the title of subject matter expert involved writing the specification, going to the facilities around the world. I've been pretty much everywhere around the world looking at these facilities, approving them, making sure that they qualify for what we need them. And this being a quality society, I'm going to be talking mostly about the quality aspects of a power transformer.
All right.
Okay. So power transformers, a lot of people really don't know what that is. So again, working for the utility, this is where you get your power from. Comes from probably a big generator, most likely using fossil fuels, creates a giant amount of current, and immediately goes to a power transformer, which it gets all this current, it transforms it into voltage, and then that voltage is extremely big, and you really can't use that for your houses. So along the way to that type of transformer and that generator goes down to your house, there's a bunch of little areas, little subs, as we like to call them, substations, and each one of them should have a power transformer. That's generally what they're used for. And this is how you get your power into your house. Miles away is where the source is, and eventually gets to your house. And from a power transformer perspective, these things should last quite a bit of time. So the history of a power transformer is really several scientists and engineers that have, I wouldn't say copy and pasted their own work, but it was around this time where the battle of scientists was happening all over the world, and the Northeast of the United States, mostly New York, was no exception. There was a lot of famous engineers that were going back and forth on them, not just Tesla and Edison or anything like that. It was quite a bit of a few people. So from 1820 to 1878 is really where you get this design that we have up to this date. There's really hasn't been a better design than what we have done since, you know, the 1800s, which is kind of hard to believe. A lot of people don't know this, but it's absolutely true. You know, the aspect of this is the physics. The physics is what really creates this power transformer. There was a man named William Stanley who pioneered the tank design, which is basically it looks like a drum, almost like a trash can drum style, completely covered, sealed, and in there are some windings, and that's what a power transformer really is two winding coils, one from each side. In there, you'll get some scientific magic, as we like to call it, and you create a different style of current, which it actually increases, and you get a different power transfer depending on the amount of coils that you do in there. A picture on the bottom left kind of indicates what this power transformer might look like. They're pretty big cylinders, and in there are a lot of slabs of metal, and a lot of that has to do with losses, and that's a whole different topic. But going from 1820 all the way to 1889, you have some famous things going around right there, like the AC and DC war of currents to find out which one was better. Turns out the AC won. There was a transformer called the ZBD transformer, which was very, very important when it comes to power transformer designing. That is because they created steps, which is basically a connection within these huge windings in different locations to give you different values of the voltage. So you can kind of use a mechanism called a low tap changer that will change the voltages for you at any given time, even though the transformer is energized. So in 1886 was the first commercial unit that was sold by Westinghouse. Many people might know that from the electrical engineering field. The name Westinghouse is very, very famous. It is one of the pioneers of commercial electronics, if you will, or anything electrical. And then a certain company bought them off later on as the years went by. And then before even the 1900s, we got our first long distance voltage, which is basically what we do at a utility, is we grab a source and we take it all the way to your house, miles away. And that first long distance voltage was 4,000 volts, which we still use to this day. So in the Northeast, again, I mentioned that this was kind of like the pioneer location for this type of stuff. We had engineers from all over the world. And in there came out a voltage that, again, as I mentioned, we use to this day, and that's because it's very difficult to update it. It costs a lot of money to update it. So to this day, there's still a good chunk in the area of New York that uses the 4,000 volt system grid, if you want to call it that. These transformers, very, very simple, simple design. If you go to college and you study electrical engineering at any point, or even electronics, you still deal with transformation, whether it's voltage or current. A transformer can be tiny and it could be extremely big. For power transformer, which you put in an electrical utility, you have a lot of accessories. Bushings, which is generally what you see on the lower right, is the things that are sticking up and it kind of looks like they have coils on it. That's a bushing. And those are basically to connect the power coming out of a big conductor, which is a huge wire, and it goes straight to the transformer without touching ground. That's basically the gist of a bushing on a power transformer. You have your low tap changer, which is the flexibility that I mentioned. This is the big box on the picture that I have right there on the left side. And that is basically a mechanism. Again, it connects to the windings inside of the tank. So that's completely connected to inside of the tank. And that mechanism allows you to choose different voltages if need be. And that has to do, again, with a whole different topic of how the utility works, is that around the house, say, for example, you put a solar source, anything that has to do with solar, it starts to move around your voltages, and the low tap changer will help with usually the utility more than the customer to maintain stability of the system. There's gauges, indicators, sensors, all of that has to do with maintenance. A power transformer does need maintenance throughout its lifetime to maintain excellence, quality, if you will. Radiators, these are kind of things like some people have in their homes. If, say, for example, you wanted to buy something with heat, sometimes any store, even Walmart, has a heat source that you can plug into the wall, and it looks like they got radiators in it. That's technically what this does, except it's the opposite. It doesn't make things hotter, it makes it cooler. The number one enemy of a power transformer is heat. It will age things very quickly. On the bottom left, where you see the windings there, that is wrapped around paper, and the quality of the paper is very, very important. And if you give that paper a lot of heat, it will dissipate, just like lighting a match really close to paper. You will see it start to burn, start to deteriorate. It's almost the exact same thing. But the radiators are actually meant to cool down a power transformer by having oil flow to the top, which is usually where the hottest oil is. Transformers filled with oil for dielectric reasons. And then the radiators make it go down, and you can put fans on those radiators. And that's what I put in there as an accessory, is that radiators, most of them have fans, because with fans, you cool down the oil a lot better. And you can actually have more capability on the power transformer if you have fans and have cooler oil within that tank. You have monitors, IEDs, which are electronic, intelligent electronic devices. That is to maintain data, to have remote operation, work with anybody that can move around the LTC remotely or gather that data remotely as well. But you can absolutely do it physically in front of it. Dehydrating breathers are just basically silica gel that grabs moisture and dissipates it. And they finally have some that are actually maintenance free, which is really nice. I don't have to replace silica gel ever again. And that's to get moisture out of the main tank as well. And then finally, there are things called a conservator, or some people call it conservator, and bottle, which means basically a tank of gas. And that is to maintain fault in oil movement when there is a fault inside of a transformer, which I'll talk about later in terms of a different slide for quality purposes on a power transformer. So a conservator is basically like another little tank that's connected to the main tank. When there is a fault inside of a transformer filled with oil, the oil will expand. And that conservator or conservator will have that space to help the oil move around. It has quite a bit of maintenance on it. So most of the time, for anything that's above 5 MVA and below 50 MVA, you might have a gas insert bottle, which is basically gas that is on top of the main tank inside and maintains a pressure in there, which you will have a gauge to indicate that, and that pressure will maintain that oil level on the transformer if there is a fault, and it gives you all kinds of indications. So there's quite a bit of things that you could do with a transformer. And again, this is all to maintain the transformer, make sure that it lasts for about 4 decades is the ultimate goal. Okay, so ratings and physical size. Again, as I mentioned, power transformers can be tiny, but for power transformers, some of the smallest ones are 25,000 VA, which is voltamps. That one's in the middle. These are pretty heavy. They're about 50 pounds in most cases, even when it's filled with oil. These you actually can see just about anywhere. If there is power lines going above the ground, if they're not too big, some of them are massive, and you can kind of see these things being bolted onto the poles. Most people, I believe in El Paso, don't get to see these because most of the lines are underground. So that's a different topic. But these are some of the smallest ones that you can call power transformers. So the low side, again, you're talking about 2 windings, high side and low side. The low side can be all the way down to 120 volts and as high as 1,110 kilovolts. So that is a whole lot of voltage that you can have on the high side and very little on the low side. The physical size, again, the one in the middle is kind of like the smallest one. The one on the left, bottom left, is what we call a grounding bank for most of the time. So that goes underground. And then we have one on the right that is what is considered one of the biggest ones, and that is almost 50 feet high. So I kind of wanted to get one that would have a person right there, but you can kind of see how big these are based on the floodlights that you can see there on the wall there's actually a small crane on the bottom left. These things can be really, really big, and you can see there the conservator on the left, upper left of the transformer main tank. That's what I was talking about in terms of conservators. Some of these transformers, the biggest ones, are called auto transformers because they technically have one winding, but you know they also generally have two. But in electrical form, it is one. Some of these can be as big as a house, and you can actually go inside of them and check out everything because it's so big in there. They have manholes usually on the top part of the main tank. You can actually unbolt those, take out the oil, get inside, take a look around. I would not advise it after a fault because it's very smelly in there. The oil kind of burns, and it's definitely not for the faint of heart if you wanted to go inside one of those. The capacities range from pole mounted, again, the one in the middle, and government protected auto transformers, which you'll never find a picture of, nor would you ever find an engineer that would talk about it because it's protected by the government. So just about every country has specialty substations and power transformers that you'll never know about because the government doesn't want you to know about. So let's continue with the quality part. So quality for these type of devices include quite a bit of things. You start looking at the specifications, which means somebody like myself, an engineer that can write up all kinds of different things for a power transformer. And it is a long specification. I'm talking about at least 20 up to 120 pages. It depends on how specific you want to be. You have to write those up based on what you are working on. The accessories, you need to make sure that you get up, quality approved, well known, very little reporting on issues type of accessories. You need to audit the facility of the power transformer itself. You want to make sure that a lot of things are going very well over there, that it's clean, that they have the right personnel, that they have personnel with gray hair. As I like to joke around, if you have a lot of people without gray hair, you will have some issues in that place. You need to have somebody with experience there, and make sure that when you go to those facilities that everything looks correct. In other words, there's a lineup that you have to pass through that says, this stage of making the transformer can be a little dirty, which is usually when you start welding, and this stage has to be very, very clean, which is when you're building the windings. You absolutely don't want any contamination on that one. You also have to go through the approval drawing stage. So you give money to a transformer manufacturer and they give you drawings and they say, does this look correct? You have to take a look at every single little thing and make sure that everything that they put in there is what you want. The winding design, again, you have to make sure that they're putting in the correct paper, the correct method of winding construction that you want to have in this transformer. There are many, many out there. The ones that are most famous for are circular. Circular is definitely one of them. And then there's humidity. Humidity is another enemy of a power transformer. If you have humidity inside of a paper type device, it will have issues. Leakages. This thing is surrounded by oil in a tank. Everything has to be sealed. And a quality of a power transformer is that you'll have 0 leaks. And you actually test this in a facility and when it arrives to make sure that during delivery, nothing happened at that point. Factory acceptance tests, which means you have to, well, you don't have to, right? But the quality of life is that you should witness personally the testing that they do on this device to make sure that everything passes per code, per standards. IEEE is definitely one of the big ones that most people follow, but you yourself can make it a little bit more stringent than IEEE. IEEE is a guide for industry-wide, but if you make it stringent, you can definitely push the quality of the power transformer at that point. And then there's delivery and freight, as I mentioned. The transformers package, it's almost like if you're purchasing a computer from Amazon. Most of the time they come in a box that is pretty much sealed very well, and it also has some thick packaging in there to make sure that if there's any bumps in there, nothing happens. Same thing with a power transformer. They like to put wrap around it, make sure that it stays clean during the delivery. Some of these deliveries are across oceans, so You need to make sure that you can put an impact recorder on it to make sure if something hits it really hard, you're notified by it, and then you have to test it when it arrives on site to make sure everything's hunky-dory, and when you energize it, it doesn't fail on you, which is one of the worst things that can happen. The key areas of this quality post-delivery. So there's pre-delivery and then there's post-delivery. So the delivery, you want to make sure that it arrives safely and is tested positively. um, Post-delivery, the thing is there, you take responsibility for it at this point. You paid off the transformer manufacturer everything that you need to. You do a site acceptance test, which means that you test it to make sure that nothing happened during delivery. You test the gases to make sure that it matches what they did in the factory acceptance test. There's no reason why the gases should increase at that point because you're not energizing it whatsoever. The maintenance of it is very, very important. If you lower the maintenance, you lower the quality of the power transformer. It's as simple as that. So the oil inside of the main tank is what we consider the blood of a transformer. So a human being can grab a syringe, take your blood to a lab and find all kinds of different things depending on what you want to look at. We do the same thing with a power transformer. We look for gases, we look for contaminants, anything like that. So the oil can be tested ever so years. Depends on your company, depends on the manufacturer's guidance. And then there's the LTC. We want to test that as well, maintain that thing because that's the only mechanical part of a power transformer. Everything is static. The LTC has a mechanism that moves around some steps in there, and that's the only real thing that moves around. Eventually, it will fail because it has movement on it. So if you maintain that one, you can anticipate when you need to de-energize everything and replace it or replace the LTC only. There are pumps in some of these transformers. The really, really big ones have pumps in there because what you want to do is maintain a physical aspect of the transformer to be pretty small. And in order to do that, sometimes you have pumps. Those need maintenance, which means you have to de-energize the entire transformer. And these are usually really big units. So it's a big deal to maintain those things. The fans don't need too much maintenance, but you do want to make sure that they turn on when they're supposed to. If they don't, whoever is running the transformer can really push it where they're not supposed to without the fans working. And all the other accessories might need maintenance as well. So if you maintain this thing, it's very, very similar to a car. Car has a lot of parts. If you maintain all those things, your car should last you quite a bit of time and you might actually enjoy it at some point. You kind of start saving money. It's the same thing with a utility with a power transformer. All right, so here I wanted to end the quality presentation of a power transformer with a little bit of humor. So I'm going to share 3 different pictures from a power transformer world. We like to compare power transformers with boxers. So boxers, the best ones know how to defend themselves and they know how to take a punch without being knocked down while hitting at the same time. Same thing with a power transformer. With a power transformer, there's a lot of things connected in between them. Again, I was talking about miles and miles away. A storm can do several damage. There could be something that lands on the wire all the way from there. But the worst thing is probably lightning. Lightning can happen at any point with the storm. So when lightning strikes, you get an overcurrent value going into the windings of the transformer. And if it has quality construction on it, that you followed every little step that you could to maintain the quality, you will be able to, your transformer will be able to resist that fault and continue on and get a little bit of damage. Every transformer will be damaged along the way. And you want to maintain it for a good 4 decades in there. So the first example that I have in terms of the best, being ASQ from El Paso, I'm pretty sure everybody knows who this guy is. He had an outstanding record, considered one of the best, and that's why I want to put him in there. It's José H. And he really wanted to continue going until he had either a loss or a draw. It turns out to be a draw in this case. So you can see there for the years 80 to 94 for a boxer. That's an enormous amount of time. For a power transformer, you kind of want to have that type of design as well and maintain quality for it. So you want to have a transformer very similar to a boxer like Julio Cesar Chavez. What could have been. So this is basically a situation where your transformer is high in quality, you know this for a fact, but something drastic happened. There have been some incidents of vandalism in utilities, and that you cannot stop or predict, and your power quality of a device just went kaput because of this vandalism. Either, they did this or they did that. The transformer has failed. So with this one, I like to compare it to Salvador Sanchez, another Mexican boxer. Give me a second. Okay, excuse me about that. Salvador Sanchez was what could have happened if this boxer continued on with his career. Considered some as the best Mexican featherweight, I would say champion. Yeah, he was champion for a few years, but he had sadly passed away in a car accident, and you never knew how long he would continue. Maybe he would have had a better record than Julio Cesar. A lot of things are what could have been. This is not exactly a bad loss when it comes to quality. It's just, a sad story to tell everybody that said, it maintained its quality, never gave me issues, but eventually, something happened to it. And, it's what we call a loss of life at that point. And then there's the third one. This is where you don't put a lot of quality in there. You're just following the industry standards. You don't witness the factory acceptance testing. When it arrives, you just energize it. You just say a transformer is a transformer, and you get something like this in terms of boxing, right? So this guy got hit pretty hard by a pretty good boxer. Again, for us, when we say that, it means that it got a fault on it and one good hit, and he's down for the count. Possibly his career is over. Very, very questionable kind of stuff. This is what you're trying to avoid when you're creating a quality product, is that you have somebody that doesn't perform very well, that you just throw him out there and see what happens. He might have gotten the training in there, which means you put in some industry standards in there, but just because you did that doesn't mean that you're going to get a quality product. In between all these guys, again, what they do is also defend very well, right? If you have an open face, you're going to be knocked down pretty well. In that area is what we call protection and control, which is an entirely different topic, but that also falls into equality of an overall product. But from a power transformer perspective, if you go through quality with all the areas that I mentioned, you should be able to have something very, very similar to the boxers on the left instead of the boxers on the right. And that's the end of my presentation. If anybody has any questions, please let me know, and thank you.
Wow, Jose, first of all, it is amazing how you integrated quality into the power transformers. It's amazing, really, very interesting. It's short, but very, very interesting. Those things I didn't know. We
Yep.
have electricity in our homes, and who cares, right? Nobody is asking
Yeah,
what was
that's the end
possible.
product, right?
Exactly. So, one question.
Sure.
At the beginning of your presentation, you said that the electricity, the voltage that is coming is 4,000, right?
Yes. The
4,000 volts
the
in the lines.
Yeah, the first long line that went for miles, and I think it was only like 2 or 4 miles long, which is not a lot these days, was 4,000. And till this day, we still have that voltage. We cannot get away from it because it
Yeah.
started that way, and it continued and it continued, and it created a small grid that if we replace it completely, it would cost us billions of dollars, and nobody has that amount of money to invest. So we're stuck
Yeah,
with it,
yeah.
and everybody in the Northeast is trying to get rid of it as much as possible.
I see. Okay.
Yeah.
So, and my next question is, in order to drop the voltage to 120, how
hmm
many steps in transformation is needed?
It's a good question. So you want to do it safely. If you go from a very high voltage to a very low voltage, you're gonna have a lot of current. And when you do that, a lot of the accessories and the equipment beyond that will not be able to handle that current. You just can't have it that big. So you take into steps. So you do one transformation a little bit smaller, one transformation a little bit smaller, until you get into a pretty good sizable voltage in there. So most of the time when you want to go down to 120, you want to bring it down all the way possibly into the 4,000 voltage level or a little bit higher than that.
Okay, okay.
Yeah.
Excellent, Jose. Well, thank you so much. I'm gonna let the rest of the group to ask questions. But
Okay.
I like it a lot. Thank you.
You're welcome.
One question for me is in the Northeast, how much affect you the heat? Because it's more cold than heat, isn't it?
Yes.
So
So
what? So
yep.
the maintenance is not so much in the oil and the heat inside the transformer.
You can do a lot of things. So Arizona, Texas, those are pretty hot places, even California. They have specifications that relate to that. So in the IEEE, when they build power transformers, they have a range of 120 degrees, and then you can manipulate everything below that to the ambient temperature that you have as a year goes on. So you have to calculate what is the average ambient temperature outside and the maximum, and you can manipulate those numbers in your design to maintain that transformer. So in the Northeast, you're correct. The colder, it's okay. The cold is okay for us unless you put a very specific oil in there and it becomes viscous and you can't even test it. So you want to be sure that you don't put in the wrong oil in the transformer in the Northeast or anywhere beyond that. Say, for example, if it was Canada or even Russia, those have different specifications for oil. So the heat is not so much of an issue, but global warming is a fact, and we're taking into that our specifications and increasing our design to 5 degrees Celsius to anticipate, I think in about 20, 25 years, the temperature, ambient temperature is going to change to 5 degrees hotter over here in the Northeast. So we keep that into account.
One more question.
Mhm.
You told us that the design it not changed too much since the beginning of
1800s.
the transformer.
Yeah, yeah.
So why is that? The AI is not helping you to build something better?
AI did not invent physics. Physics is physics. There's only certain things that you can do with certain things. The space is not available. The transformation can't be done correctly. So we have advanced technology computers that all they really did from that time until about the 1980s is that they corrected over designing. So in the past, before the 1980s, our design was over designed. Our power transformers could last 60, 70 years, and there's proof of it right now because we didn't have computers. We had calculators and mathematics in your head, and everybody would over design it. I wouldn't say accidentally, but they were over designing to make sure that it did its job and not worry about it failing. So most of the transformers back in the day was 20% over design. That's why they lasted so long. Nowadays with computers, manufacturers want to save money. So they have a very tiny little, 0.1, 0.2% of an over design, and that's about it. You get what you pay for at this point. So I wouldn't say that we've advanced the technology. I would say I wouldn't say under designed it either. We have designed it very, very accurately to the point that we know how long it should last now. And AI hasn't really helped in that. It's just a matter of physics. You have to do a transformation of this voltage to this voltage in this very contained area, and you cannot make it smaller. You should not make it bigger for various reasons. They have a lot of variations, losses, eddy losses, overcurrent, circulating currents. So there's a lot of reasons why we have it the way we have it. We really haven't changed it, and that has to do with physics.
One more for
Okay.
me. Okay, I know electronics a little bit,
Mm-hmm.
and I know that transformers is just two winding,
Mm-hmm.
primary and secondary. And the
Yep.
primary
Come
you
on,
enter
don't be humble, Hector.
so they come a bunch of voltage in this way enter,
Yep.
and you just get whatever you need out and then another in the
Depending
secondary.
on the amount of turns. Yep.
Okay, based on your experience, which is the companies that make the best transformers? power transformers for your company?
Oh, okay. So based on my experience, the industry would get a little mad at me, but I would say Waukesha in Wisconsin makes the best ones. Everything that they have done for all the companies I've talked to, they are the best. They give you the least amount of issues, no leakages, no nothing. They give you everything quality, including the drawings when they give it to you in a binder. The binder's fancy. Every drawing is in a plastic case. The transformer never gives you any issue. They over-designed it. I know that for a fact. And they're the most expensive. So again, you get what you pay for at this point. Their name is very, very well known in the industry. When somebody wants to create a new facility, they go to them most of the time to see how they do it, and they get their blueprints. They hire them sometimes to kind of construct their facilities. So Waukesha, unfortunately, has been purchased over and over again in the recent years. I'm not sure why that is, but right now General Electric owns them, and they're the best facility, the best manufacturer we've ever had. There's a lot of big names out there that'll get mad at me for that one.
Okay.
Excellent, excellent.
One more question for me.
No, sigo yo. Sigo yo.
The transformer, why it needs to last for decades? Why?
Okay. It doesn't need to. It does not need to. Utility standards say 22 years. If you push it at 100%, this unit will last you 22 years. The reason why I say 40 years is that you want to push it to 50% capability. The reason for that is because 40 years will give you a lot more money back as a customer than 22 years. It's twice as much. So in a location where you might have one transformer to push it at 22 years, you put two transformers that last you 40 years, and each one is pushed halfway, about 50%. So a lot of companies do this to make sure that you don't have to worry about it for 4 decades. Everybody likes to call it, my retirement plan, because most of us are at that age where 40 years from now you're going to be retired. Like, you just want to drop it there once and forget about it. So it's a 40-year for quality, but you don't have to do that. You can follow industry standards and do the 22-year and worry about it, when you're in your 40s, worry about it again when you're in your 60s, instead of never worrying about it.
Thank you.
Yeah.
I let Dr. Poblano ask her
No.
questions.
Adelante las damas primero.
I have a question, me.
Mm-hmm.
Okay, you've been saying a lot about physics. And it looks like for my students, the ones that are getting EPCC certifications and diplomas and everything, I can go ahead and tell me if they're interested in engineering, especially on working on that. Would be physics and materials, or what would be the other classes?
Classes. Okay, so
Yes, remember
power
you took
engineering. Yeah,
power
power
engineering,
engineering. Transformation is another one.
transformation.
Yeah. In electrical engineering, all 3 physics 1, physics 2, and modern physics. Yeah.
One,
Oh.
and modern.
Yep.
They should ace those.
Yes. If they do not ace them, they will not get hired for those facilities.
Well, of course, we need the electricity, right? We have to have the
Yep.
best of the best, like you've been.
Yep.
Okay,
Yep.
and what about soft skills? What soft skills do they have to require or gather?
To do what?
Like you are supervising some engineers and you're expecting something from them. Like follow the right instructions, follow, I don't know, the reading instructions, or go to the meetings.
Yep. Soft skills. Constant communication. That's definitely one. That is definitely one of them. If you're not talking to them constantly, they're going to get stuck. You won't know about it. Things get delayed. Constant communication is definitely the number one soft skill. The other one is maintain a schedule. So if you're talking to them all the time, if you don't have a schedule, they'll tell you, I'll do it next week when you actually need it on Friday, something like that. So You want to maintain a schedule. Spreadsheets are a great tool to maintain that. You can write up an objective or a milestone and put a date there. You can also put notes in case if it's delayed, you know, to explain to your boss what happened. So yeah. So communication's number one to maintain supervision and make sure that everybody's going smoothly. And then number two is the schedule.
Okay. As a teacher, thank you very much.
You're welcome.
Jose, I have a question.
Sure.
Do you speak Spanish?
I do, but not in engineering.
Okay, muy bien.
Yeah.
Because I'm so tired to try to speak English.
You can ask your questions in Spanish. Haz las
Yep.
preguntas en
Yo
español.
sé que José. Bueno, lo que entendí y en lo poco que tengo experiencia en los transformadores, pues realmente lo que ha ido cambiando es el tamaño y que son más eficientes, es correcto, ¿no? ¿Tú estás en El Paso, Texas?
No, estoy en el estado de Maine. Okay, so the size of the transformers. Yes and no. So the size sometimes can give you issues, sometimes it cannot. The size will allow you to put a little bit more oil in there, a little bit more space between a winding and the edge of the main tank. So pretend that you have a box and that box is the box and you put something in there. And on the edge of that box is that something, if it's a little too close, if you have a fault, you will have issues. The closer it is, the worse it is. So if you have a good spacing right there, it should be good. But if you have too much spacing, you're going to have a lot of losses in there because you're doing electrical, again, I like to call it electrical magic in there, but the magnetism in there will create some issues if you have too much space. So it's a little bit of a dance. Everybody's an artist that makes a transformer, especially one that is quality. That means you're a true artist. If you make one that fails all the time, I would say you're just a painter at that point. And you're not really an artist. You're just, following directions and see what happens and make something that nobody will really be inspired for. So the size can be a friend and it can be an enemy.
Te comento porque cuando andes por acá te voy a invitar a que nos visites en el TEC. Tenemos un transformador o una unidad, una planta de energía de más de 60 años que sigue
Sí.
trabajando.
Sí.
Pero está casi, yo creo que del tamaño de donde jugamos billar en la casa de Orville. Ese tamaño está. En el gimnasio está operando. Entonces, en cualquier momento va a dejar de funcionar y a ver en qué problema nos mete. Muy interesante.
Mándale un recado. Mándale un recado a José con los problemas y todo y dónde se puede comunicar y él te avisa.
No, vamos a hacer un diagnóstico general, nada más que sí me llamó la atención.
Lo que pasa es que tiene muchas pérdidas, se me hace ahí.
Sí. El que siempre es limitante es el presupuesto, no el dinero.
Sí.
Sí, está muy limitado y tenemos que hacer maravillas. Pero pues la energía que utilizamos aquí es 110, 220.
220.
Pero sí, muy bien. Gracias, José.
De nada.
Quisiera comentarles algo porque me tengo que retirar. Me está esperando Macario.
Ya nos vamos.
Vamos a discutir fríamente unos temas. Primero, tenemos pendiente ya sea una visita al Paso o por videoconferencia para la línea Express.
Yes, sir.
Aunque ya Orfil es un experto, pero yo creo que el fin de semana podemos darnos una vuelta para 15, 20 minutos, apoyarlos en eso.
Por favor.
Thank you.
Y la otra situación, ya ahora que hay cambio de jefe de posgrado, vamos a empezar a promover la inscripción de alumnos a lo que es ASQ El Paso. Por ahí ya tengo alrededor de 9 o 10 personas que se van a integrar sin ningún problema, pero tenemos que esperarnos para agosto, que van a entrar otros 5 más.
Thank you very much,
Okay,
doctor.
perfecto.
Perfecto.
Dr.
Sí.
Poblano,
Y,
are you
seguimos.
still there? Nos gustaría ir al tecnológico, a Héctor y a mí, y platicar con los estudiantes para inyectar algo de entusiasmo en que se enrolen en lo que es ASQ y los beneficios que pueden tener enrolándose en ASQ.
Están de vacaciones ahorita y empezamos hasta la tercera semana de agosto.
Thank you, Dr.
Okay,
Poblano.
that's fine.
Let me know.
Todo
Okay,
julio,
okay, yeah.
todo julio está cerrado el TEC, nada más gente de mantenimiento y de limpieza, aparte de los guardias trabajan. Bueno, hay cursos de verano y cosas de esas, pero podríamos también en julio buscar un grupo, hablar con Macario y quizás invitarlos. Los de posgrado es más fácil porque como llevan temas de calidad, se van a interesar
Yes.
más rápido. Y
Thank
como
you.
que hay que
Right,
pagar,
right.
aunque hay que pagar 35, $40, pues a un estudiante de licenciatura se le complica más.
Sí.
Pero
Thank you.
lo planeamos con gusto.
Y,
Thank you,
okay,
Dr.
la
Poblano.
otra cosa rápida que queremos conversar contigo es las posiciones que tenemos disponibles en ASQ, en lo que es el Leadership Committee, y pensamos mandarles cuál es el rol que juega cada posición para que las veas tú y nos digas, a mí me gustaría participar en esto, ¿ok? Pero te vamos a mandar esos, son como si fueran los job descriptions, ¿ok? Pero para que
Y si
sepan,
no,
que no nomás se te queden con el nombre.
si no buscamos a alguien más que también quiera participar, sobre todo en el área de posgrado.
Yes, sir.
Órale.
Está bien.
Sí.
Ok,
De
Thank
nuevo,
you.
gracias
Gracias.
por
gracias.
invitarme.
Poblano.
Gracias,
Gracias.
Poblano. Gracias, doctor Poblano.
Tu primera junta en ella es excelente.
Thank you.
¡Ay!
No, Juan,
Thank-
estaba dormido.
Bye bye.
Perdón.
Casi, casi, 9:30.
Estoy aquí desde
No,
las 7 de la mañana.
Ya lo creo, ya lo
Pobrecito,
creo.
12
Wow.
horas.
Me toca un poquito.
Sí, sí.
Bueno,
Gracias, mijo.
hasta luego.
All right.
Gracias.
Bye bye.
Gracias, José.
Gracias.
Bye.
De nada.
gracias, gracias.
Estamos en
Josecito.
contacto.
Gracias. Bye.
Sí,
Ok,
contacto con José y contacto con nosotros. Ok, bien. ¿Ya vieron a Héctor?
una